over 18 plus years of experience, especially into cybersecurity, application security, supply chain management, application security. And she also has authored over 8 books on this topic. So she holds a lot of knowledge that, we'll kind of get a glimpse of that today. And I'm also happy to introduce Sharat here. Sharat is founder at RiskSek Pro, a company that has a very, very interesting product that covers the holistic security of your DevSecOps risks, your cloud security risk, your software security risks, and we'll know more about that soon. But the format of today's topic or today's session is first we'll have session from Hanim to know about some fundamentals on application security and its overview. Then we'll have another session from Sharat, going deeper into DevSecOps and cloud areas. And post that, we'll open for Q&A. So feel free to type in your questions in the chat. And also after these sessions, 2 sessions, we'll open everybody's mic so that you can also interact with the speakers. So with that background, let's get started. I'll hand it over to Hanim. So Hanim, over to you to get started your session. Thank you.
Thank you. Thank you. I stand. You can see my screen. I think I can start.
I can see. I hope everybody else also sees the screen. If you can confirm, if the attendees can confirm that.
Yeah, at first I want to start to explain why application security important. These days every applications are used all of areas of our life. At least every person has a social media account or email. Because of this reason, application is everywhere in our life. Also, a company or organization has used and a software, their business process or like this. Because of this reason, application is everywhere in our life. Also, they make our life is very easy. We can do everything on the internet environment at home. But when the application is not secure, it's a bit problem for everybody, because this application running is mobile phone, computer, IoT devices, smart devices is very popular. Generally, most of them is run internet. Therefore, everybody reached this application. Also, hackers is reached this application, and they test for the 7 days, 24 hours in a day. This application connect various network and cloud environment, communication to each other. So if the application aren't secure, they are increase the vulnerabilities to security threats and breaches. So this these threats influence to everybody's life very much, because sensitive and still sensitive data, it can be very important crime, cyber crime for the people's life. Because of this reason, application security is important everybody in the world. Also, according to Gartner, 21% of the vulnerabilities coming from the application layer. The important topic, application security or software security in recent years. Software security and application security is not same. People generally use instead of each other. It is interchangeable, but application security is a subset of the software security. Software security is covered the application security. Software security is include generally at first of secure software design architecture. It is very popular in the recent years. Why? Shift-left security is very popular. It is help to developer or companies or security team for the cost saving and time saving. When you secure your application is design and architecture phase, it is very fast and easy. Another important thing, software security is input validation, because many vulnerabilities for the software side, it is like SQL injection, cross-site script, everybody here, if you're a developer here, their life. Input validation is important. They requirements put in the beginning of the developed application. Session management, use access control level is very important for the software security side. Why? Because most privilege escalation or unblock authorization or access the unauthorization people to data, still sensitive data, because of the not good management about the access control, user account or session management. Last 10 years after the SolarWinds attack, software supply chain security is very popular. Also, it is very effective. In the most of the supply chain attack, it stopped the company's organization business process. Also, it is influenced who is the user this application or which application using these third-party resources, components, libraries. It can be open source or commercial component, no problem. It is not secure. It is a big problem for the software security. Another thing, securing the coding. It is about the generally scan the source code when you develop the application in the development phase, and then generally companies or organizations or security teams using the tools to for the scan their code. Some tools open source, some tools the commercial. They choose their requirement, and after that, tools find vulnerabilities in the application. This generally is these vulnerabilities by developer. Then developer can fix immediately in the development phase. They don't need to wait until the running the application in the production environment. After that, for the like this security requirements is development for the guidelines. Training is very important, and process or produce or standards for the deployment phase or secure configuration side. But application security is generally after the start, after the running the application in the production environment. Software security is before phase deployment phase, but application is start after the deployment. So before the deployment, security test important. It can be used vulnerability management tools or penetration tester used for the find vulnerabilities in the application before the deployment running the production environment. Then in second things, application is running a web server or any server or anything or some network. Because of this reason, software environment configuration, secure this configuration is important. Other than after deployment, patch and upgrade is continue. It is about the source code side, because maybe you need to application fix the bugs or vulnerabilities. Also at the other side, you need to patch or update for server and network side. IP filtering is important because it is give the further restriction your application. It depends of your requirement, application requirement. This application needs to reach by everybody, or maybe it is you can restrict the IP filtering like geographical location or on maybe VPN peer-to-peer connection. It is like this can be secured for application. Another thing is very important for the application security, software security, or other things. Continuous monitoring, incident response management. This incident response management start for application running the production environment. So in here, it is related to previous.
Hanim, sorry to interrupt. I think one of the participants wanted to request if we could. I mean, even if we move slowly, it's fine. I think they just wanted to gather this concept better.
Okay.
So even if we go over time, I think it's fine. Yeah.
Okay, I talk fast because of I talk too low. Okay.
That's fine. I mean, it's just sure. Thank you.
Okay, maybe okay. If I time, I can talk. Okay, no problem. Okay.
Sure.
The another thing is it is again related to for the previous slide. It is about this is how can they integrate security into application development. It is at the same time related to integrate your security in the software development lifecycle. It first is definition phase, threat modeling. What is the threat modeling? Threat modeling is at first identify the risk from the potential risk or threats in this application, then prioritize this threat, then how can fix this threat in our software when you start design and develop the application. So after identifying the threat in the design phase, you say that this according to this architecture, this application or software has like this threat. So I need to put this requirement for example, maybe network side, maybe develop the application or man the access management side. So put this security requirement is design review. It's same. The another meaning is shift left security, because when you put in this protection or remediation in the design part, it is easy for the developer side, architecture side, because it is time saving, cost saving, and effort saving for the every part, every team in the software. And after the finish the design review about security, it is development phase when your developers start to write the code. It's generally at the same time, it's good for the scan this course for security by tools. These tools generally finding vulnerabilities, it's OAuth top 10 or other NIST application vulnerabilities, and show the developer when they, most of them show their development environment, so they can fix these vulnerabilities very fast when they continue for develop the application. After finish the developing and applications start to run in the production, it is very hard to vulnerabilities, because I have a software developer experience at the same time. I am now very hard. Also because of this, I started interested in the application security side. So it is very hard. It must be doing in the development phase. Also another things, secure software coding, and the developer needs to train, educate the front, how can they secure their codes. Also, its maintain phase can be doing, but at the same time, in this phase, training starts this development phase, because at the same time, developer learn. When you next time develop the application, they can be very better than the because of the previous experience. And after the development phase is deployment phase start. This is at the same time is continue for that functional testing from before the deployment. At the same time, security testing is doing before the deploy the application. This finding is fixed before the deployment. It is generally, it's not about check the code. It is checked for the vulnerability management tools or penetration tester. It's from the user interface, like in the production environment, like a hacker. It's doing the testing and find all the vulnerabilities before the application running the production environment. After the finished development side, writing the code, it is maintains phase. It is mean that this application running any device, network, system. This is the secure configuration management important, because therefore the server, web server generally must be configured very well, change the default settings, also network site port numbers or other things must be configured very well. After that, the maintains phase. Another is access control. Access control means role management is important. Also, for the space for the API side, which user is used the API. So it is account management is very important for the API and cloud environment. Access control and access identity management is important. After the access control, they need to regular update and patches, because now your application is running the production environment. So always you need to regular update your application, maybe finding any bug or any vulnerabilities you update. But when you update the application, maybe you can create new vulnerabilities. Also update and patches is included to systems and network update and patching. Regular update and patching need. Security training is, I put in here, but I think security training is every part of these phrases, because at the same time we continue learning. Also, it's for the code side, security training is very important to developer. For example, I have a penetration test experience. We found vulnerabilities when you go to developer doesn't know how can fix. Because of this reason, security team or companies educate developers about how can they write the secure code, how can they fix the vulnerabilities after they find these vulnerabilities. Another maintenance phase is it include continuous monitoring and incident response together, because continuous monitoring is important too for the at first business continuity. Your application is running very well, everything's okay, everybody reach your applications. It's about for the performance. Also, it is important for the understand unexpected behavior, your application log management, or as a hacker try to hack your system on any attack for the C, like these things, incident response and continuous monitoring for the important for application development, software development life cycle. So securities can integrate the software life cycle like this. I want to, after the generally, I give the summary things about integrate the security for the software development life cycle. I want to talk about software supply chain and cloud security. It is very important. At first, supply chain security is very effective for the companies or organization, because in the last, I think, 5 years, I always hear that a supply chain attack from the applications, because nowadays developer using a lot of third-party resources. These resources can be open source or commercial. They must use it because their development environment or deployment environment need to like these components or tools. So at first, companies or organizations can their open source or commercial packages, containers for the vulnerabilities. At the same time, this gives the companies or organization to know their software materials of builds. They understand, for example, a developer download a framework for the developed application. Generally, they don't know which components is included. When you scan for like applications like these tools, they know for the software materials of materials. So it is give the information about license and security risk. These components has any security vulnerabilities. Also, nowadays is open source license is very popular, because open source license means not free. Every open source license have any requirement. So, for example, open source license doesn't give you to use your component in your application, and you can sell this application. So, developer must be careful about the open source license requirement. Also, it is this component is secure or not. Many, for example, attacker find any vulnerability, the component, they can try to attack these components vulnerabilities which application use it. So it is very effective and very easy. Nowadays, generally, companies is focused on the software supply chain security. At the same time, after the developer decide to use the correct packaging software, they need to train and educate again for the developer teams to understand what is going on. Another thing, cloud at the same time, I think third-party resources, because nowadays all the applications running the cloud environment. Also, they keep the source code from the not source code, but database data is keeping the cloud environment. So it is very important threat is the cloud environment misconfiguration. Maybe people don't have enough information or configure wrongly or default configuration, especially for the identity management, access control. The main reason for the data leak is misconfiguration of the cloud environment. Also, again, is API. Is insecure APIs is important because when you use the insecure API, maybe your cloud environment is okay, your application is okay, but API is insecure. It can be for the data leak from the cloud environment or application. Also, APIs is very important for the application or software. Why? API is pipeline for the data transferring, and also all application communicate each other. Application develop the different language, but they communicate to each other by API. So API security is very popular and important for the security application. I think in the future, API security will be very important topic because I think API using the API increased in the future. It is easy and also doing something very fast. Common attacks for the API attacks, denial of service, DDoS attack, it's same. Generally, because of this reason, is not good management for the access control side, or because API is important, which person is access to this API. Also, IP filtering is very important because you restrict for the your who reached this API. So DDoS attack is very popular and affect too much because, for example, your system is for the request for example, 10 people at the same time getting the 100 requests in the API, it gives the DDoS attacks and normal user cannot use or reach the API. Man-in-the-middle attack is generally is about attackers position themselves between users and system application and intercept the network, and they behave like normal user, or they change the data or request. Also, they can steal the data. So it is important part for the main protection, the main in the middle encryption network using. Also, again, for the access management is important, but be sure this user really your real user, or it can be attacker. Like this prevention can be protect from the man in the middle attack. Another thing, again, broken access control attack. It is same for the privilege escalation, authorization, access control attacks and problem. It's related to access control management and like this. Another is injection. This injection is generally can be SQL injection, XML injection. So like this, attacks can be stopped with the input validation. Developer must be very good input validation from their API applications. It is a lot of attacks can be talk about the API attacks, but this 5 is most popular attacks in for the API. Thank you for listening to me. It is about my background. It is my LinkedIn and email. If you want reach me, you can connect for LinkedIn or email. Thank you for listening to me.
Thank you, Hanim. I mean, that was indeed very insightful session and very informative. And just to summarize, like you said, security in the DNA, or, starting security right from the design phase. Because traditionally we have seen SDLC as a cycle, right? That goes from requirements until your last deployment or post-production. So software security must be implemented right from your requirement, design, deployment, coding, everywhere, right?
Yes.
Otherwise, there is a possibility that these processes, technologies can be exploited. The other part, importantly, you mentioned about the collaboration, which is indeed very not so easy, because traditionally developers have worked, in isolated spaces. They like their own liberty and freedom when they code. They always want an environment where they can research, right? They can download open source tools. They can, integrate third-party applications, and then all of this integrating into your app obviously creates more and more vulnerabilities. It could be SQL injection, it could be cross-site scripting, and many more. I mean, all of these are listed. So that was also interesting, concept that you shared. And the key for me definitely was, making sure that your developers are always trained, because to code is one thing, but then to know the security aspects in your code, like, code reviews, secure code analysis, TAST, DAST, these are, concepts that every developer must know, and that comes only through continuous
Yes.
education. So that just set a very strong foundation, your presentation. Thank you so much. And with that, I think we'll move to Sharat. I think he'll take us through other concepts on the cloud and DevSecOps. So Sharat, over to you.
Hey, thanks, Santosh. I see about 50 people here, so it's certainly an interesting topic for a lot of people. Uh, Hanim, that's a very good presentation, giving a good background of application security and some of the concepts that I wanted to mention as well about the shift left security, right? So anyway, my name is Sarat Lingamallu, and I'm the founder of RiskSek. Our motto is to provide a holistic view to cyber risk. As part of it, this presentation is about some of the concepts that Hanim mentioned, which is shift left security, right? So as you probably see in your organizations, most of the times, or in many organizations, security is always an afterthought. Once you build the entire applications, and then it gets to the security teams. Now the security teams find some issues, and then goes back to the application teams to figure out and resolve those issues. So it's most of the time it's back and forth, and that's the frustration that developers normally have because they spend a lot of time building everything. Now the security folks comes into the picture and tries to find issues, and obviously finding issues, it's not always fun, right? So 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 with that saying, that's the Santosh, you can get to the next slide, please. So with that said, the difference between the traditional and the shift left is basically ensuring security right from the design phase. You have multiple stages in your dev lifecycle, right? Like right from your collaboration, developing, coding, building, then putting in the cloud. There are multiple phases. So shift left is all about ensuring the security best practices are followed right from the design phase. So it's an integrated security, approach, which really helps in identifying the issues at a very, very early stage rather than spending all the time in the dev process. So with that, the importance of security, with the integrated approach, we could also say security is actually prioritized and also incorporated from day one onwards. And Santosh, next slide, please. So let's say you have this particular screen here where, this is a traditional process where you have your developers. I'm not sure how many developers or security folks on this group, but I'm guessing it's a mixed set of people. So you have this traditional approach. You have, like I was saying, there are multiple areas like collaboration, code, building, testing, deploying, and run. And that's when, let's say, if you take a 4-week sprint, 2 weeks normally goes into the dev phase, and then the other 2 weeks goes into the deployment and the testing phase, practically speaking, right? It could be 2 weeks or 4 weeks. So it's pretty much like 50% of the time developing, and then 50% of the time is pretty much testing and evaluating this. Now, imagine that, like I was saying before, now the security teams comes back and say, identify a bunch of issues, which we practically see with our clients as well. Now you see the 4-week sprint, the planning, goes hayward. Now, basically, if you want to release a feature within that 4-week sprint, now you're pushing it to the next sprint, which is basically a ton of time loss for the developers, fixing those issues, and then, hundreds of man hours that goes, increased effort to build that entire thing again. And we see this all the time. And then, obviously it boils down to the financial loss, right, for the organization. So if there are any any security engineers or engineering managers in the group, this is one of the pain points that you probably see, and this is one of the things that you could approach to your management, saying that this is how it's been, right? So next screen, Santosh. Yeah, so what we are trying to say is, like Hanim and Santosh mentioned, secure by design, incorporate security right from the design phase, which means that, understanding or understanding the whole design in the first place and trying to incorporate your security practices, such as your authentication controls. What kind of technology that you can use for your authentication controls, or your who needs to be authorized. What kind of encryption that you got to use. If you got to use some kind of API gateway or DDoS protection, all these kinds of things will come as part of the design phase. And along those lines, right from the there are two pieces in the design, at the infrastructure level, and then there is the application level. So all these things would be considered the design phase, and obviously during the dev process, you already have your coding standards. Code reviews are already being practiced, and automatic security testing must have to be implemented to ensure that the developers or the DevOps teams are notified appropriately whenever these issues happen. Right? And obviously the benefits, like I said, is a bunch of cost savings. We practically see that with a lot of the clients that that we deal with, especially the collaboration between the DevOps teams drastically improve when you talk about the security from the design phase itself, because now you're actually getting the security teams are actually giving a lot of inputs to the to the developers and DevOps teams, so that the developers can simply follow these particular standards, so that you don't have a confusion of what is right and what is wrong, because you're just following what people are saying or what security teams are saying or telling you, right? I hope that's making sense. Next slide, Santosh, please. Yeah, so here is our product. I know we've been talking in a theoretical way, right? If you look at this is a practical, much more practical approach. Our product is called Flying Duck, which is ensuring the security at each and every stage of your deployment process. Like we were talking before, for example, you have collaboration. You have probably using Jira or some other tools. Now, do you have your PRs approved to get into production? Now, when you come to the code stage, like Hanim was mentioning, obviously developers use a lot of open source libraries. Now, what happens with those open source? You take those libraries, you build something, and you commit, and then you deploy, and then you test it, and then finally we identify, there's a bunch of issues with the open source libraries. Now, with this product, what happens is once you commit the code to your version control system, such as GitHub or Bitbucket or whatever, we immediately flag, for any kind of vulnerabilities. We say, we notify you saying that there are vulnerabilities in these particular set of libraries. Now, it's a decision that you can make quickly, whether to use those libraries or you got to change those libraries to continue the process. So as you see, you could actually skip all those build, test, deploy, run, testing, all those processes once you start using the product, with an integrated model. Right? In a similar way, when you go to the build, again, you integrate something with Jenkins. We, we identify, we discover all your pipelines. We analyze the security within the pipelines, identify the guardrails, identify the secrets as part of the entire process. Right? Same thing with the testing. We integrate with multiple, for example, for using SonarQube or any other tool, we kind of integrate within those tools and identify. At the end of the day, we will be correlating all this information. Like I was saying before, right at the collaboration stage, if you don't have a PR, right, and then something got pushed into production, now we can correlate back saying that what happened, why it was pushed, who got approved, all those things. So we kind of help you from that particular, right from collaboration stage till you deploy in the cloud, includes your CSPM. Like we were talking before, cloud posture management is pretty critical these days, right? There's a lot of issues going on with the cloud. Cloud is not secure by default. Now, even the cloud providers say that, it's a shared responsibility model between the cloud provider and the customer. Now you have certain components that are secured by the cloud provider, which is basically their infrastructure, and your application and your infrastructure sits on top of it. So you're completely responsible for that. There's a ton of issues that's happening out there just because there's a lot of configuration issues within the cloud. Same thing with multiple other DevOps tools as well. For example, you take you code, right? You put that in the version control system, and you always consider the security of the code, right? But you actually forget the security of the version control system, such as GitHub itself. So, for example, we have about 30 different controls that we can ensure your GitHub is actually secure. Which, for example, the forking, very simple thing. Now, if you don't have it enabled, there is a very high possibility that your developers could, inadvertently copy that code into their personal repository or fork into their personal repository and make it public as well. This happened to one of our clients. Basically they have a version control system. They have a repository. Their employee by mistake copied into his own personal repository and then made it public, right? Now imagine once you made it public, there's always hackers out there who is scanning for these public repos all the time. Now the code is out there, and even the worst, if you put any secrets as part of it, like code, when you code, you hard code secrets into your code, and those are part of it. Now, everything is in there where the hacker can get access to your environment very easily. So all those controls are part of, which are called guardrails, part of the system, and all of these must be taken care of. Right? So with that saying, security right from the design till you put in the cloud is absolutely important. Visibility is much more important. For example, you get this Log4j, we heard of it a couple of years before, right? Now people struggle to even identify where this particular library is being used in the entire code base and the entire environment. Now with the products like ours, it's easy to identify with a single search, quick search. Within few seconds, you get to know where Log4j is being used in every repository out there in your environment, right? So the visibility in the asset inventory is particularly very important when you talk about the DevOps and the cloud architectures. Yeah. So I know we got a lot less time now. So Santosh, I think we could move on to the next set of topics. Thank you.
Thank you, Sharat. I think you covered the entire SDLC cycle really well, and then again reiterating the importance of including security in the design phase is certainly the most important message. Thank you so much again. Meantime, if anybody has any questions, feel free to raise your hand or drop them in the chat box. I have received a couple of those questions in the meantime. I'll take, but anybody in the audience wants to talk to speakers directly, we'll unmute and then make sure that that interaction happens.
Yeah.
All right. I think the question that we have received from Jayant, it's in line with what you covered also, that what are the considerations for design review and code review with respect to security? So I think one is shift left as a whole, and then also the code review, because that is another important control in the software security. So if you want to share your thoughts, I mean, anybody, Sharat or Hanim?
I can start. Generally, design review is, I think, at first step for the shift left security. In the design side, it's important topic is threat modeling, or maybe every company is not have a threat modeling team or other thing. If someone understands the security to see before the start application is architecture side, they to find which part has risk about the application. Then put this requirement in the, for example, I give input validation. I give example, you have a login page. If your login page, you must be very good input validation for username and password. If you don't, it's popular at first SQL injection vulnerabilities. Therefore, it must mention like this risk for the design part. After the put this requirement, the design part in the code security side. Okay, you put requirement, maybe a developer knows and try to fix, but sometimes missing something, or another thing is code review. Okay, we know everybody is good person, but sometimes companies organize insider threats. Because of this reason, code review is very important to find malicious code for the insider threat, but can be no insider threat. It's very good developer, but they don't have enough information or knowledge about how can they develop the secure code. So it is generally using the tools. The tool is very popular now, very successful for find the vulnerabilities in the source code, but sometimes it is create very high vulnerabilities. So before the send the developer, a security person check in which one is the post positive, which one the real vulnerabilities, then developer at the same time can fix these vulnerabilities. But some tools very successful, but most of them has post positive. Because of this reason, before the sending report the developer team, a security person check in this false positive or true finding, then developers start to fix this finding. It is, to my experience, two parties very important for code security side and design side.
Yeah. And I just want to add one more thing on the design side. Threat modeling certainly a very critical aspect, and also understanding those data flows, right? When you visualize your application, right from how your users are interacting with your application servers and to the database servers and to third-party integrations, understanding those visualizations and putting the data flows together and assessing the security controls on each and every data flow is also quite important. For example, when you build the application, and most of the times, for example, when you go to the compliance, a lot of times there is a very basic questions. Are you following encryption standard? Yeah, it's a common standard that people should follow, right? But when you practically approach, are you following encryption standard at each and every area of it? Not just one data flow, not just two data, every data flow, encryption, transit, rest, all those kinds of things. But when you put together those data flows, only then you could really think about what security controls can be assigned to each and every flow.
Sure. I think you covered all the important aspects here. Hopefully that helped. I think we have another question also coming up here. So I think based on what you both mentioned, important part is making sure you have security controls implemented in the design. Make sure your design covers all the aspects to protect the confidentiality, integrity, and ensure availability of your data, right? And then scanning the source code is very important. Not many organizations do that. So you fix those vulnerabilities right, before even it is deployed. And once your application is built, run another, dynamic or web application test. So that kind of make sure that application is secured when before it goes live, right? The other question, interestingly, we have been talking about this collaboration, right, between developers and IT teams or security teams. Now, in smaller companies, these security teams may be absent. It could be just only IT teams, who are managing security. So, developers, again, they work in silos. They are very focused on their priorities. They want to get it coded, get it out there before, their sprint ends, out for deployment. Security teams, they have different priorities. So how do these two teams come together, collaborate? What is that, can be done to improve this as a process?
I think I can go first. So based on my experience, it's more of a, working together, right? How do they work together is different from each organization. In the smaller organizations, you pretty much go and tap them and, talk to them and understanding the requirements. But in large organizations, you get certain requirements, you get certain templates, and then you follow those templates, collaborate with the security teams, telling them the issues that you face and stuff like that. But again, with my experience, when I worked with my organizations and with developers, we shouldn't be seen as a roadblocker. Security teams, especially, we are not roadblockers, and we need to communicate that clearly to the dev team, saying that we are there to help you out in in building the secure applications. I completely understand the priority for the developers is always about the functionality. That's understood. But at the same time, the security team should go ahead and tell these people that they are here to help them out to build their secure applications, help them where they want, not just as a roadblockers or not just people who are complaining. And that actually worked for us. We followed the same process. We are like an extended team for the developers, helping them out so that they get that level of confidence and that we are helping them out. And then, they kind of interact with us more, open up more to understand the security in the first place and also implement it.
Sure.
Also, I want to say this part is important to me because I am developer experience. So after the change to my security, when I worked in IT 10 years ago, to be honest, operation, security, and developer didn't work together. After the DevOps started for the people, it's DevOps teams, is developer and operation start to work together. And nowadays, it is generally developer, operation, and security work together because they must. Recent years, that area after the coronavirus, everything going to digitalization. At the same time, it is increased the security threats. Because of this reason, they must be work together because they must be fix the vulnerabilities very fast. They communicate to each other. Also, my previous experience, really, security team understand the developer mindset. Because sometimes their expectation from the developer is very hard. They don't have experience. How can they fix the vulnerabilities or how can they develop the application? They think that they are very easy, but for the developer side, not easy. Because of this reason, they want to be understand. They train each other and work together, and it is very popular is now. And so generally, large or small companies try to work together, but in the small companies, maybe it's not enough resources for the operational or together work together. But generally, I am agree for Sarat. Generally, large organization can be work together and collaboration because it is very important to being successful.
Right. That totally makes sense. And there is another interesting question from, I see, Nikunj, right? During the development of mobile applications, both Android and iOS, what could be key security testing areas for QAs to ensure application security, right? And are there any industry standard tools, softwares used for checking app security? I mean, some of the tools that I know of, AppDome, and then there is Flying Duck, there is AppNox, MicroFocus. So good number of tools. But I would let you guys also share your views. Yeah. Anybody?
Yeah. So during the development of iOS and Android apps, it's pretty much the same kind of standards that we use, like we do for the application security, right? Or standards that we follow. And obviously, after the fact is your IPA files and Android APK files, or like some of the tools that Santosh mentioned. We also use the same kind of tools, and also there are for Android especially, we pretty much go with open source stack, which works very well. For iOS, we use a different set of industry standard tools, like Santosh was saying.
Yeah, and then from a testing perspective, I think the authentication and encryption are the key areas to check, right? Making sure that an unauthorized user is not able to access your data anywhere, and data when in transit or when it is stored on mobile. I mean, there should be minimal.
We got about 100 plus set of use cases to test each and every application, including iOS and Android. So it's a bunch of things that we need to check, other than the Santosh that you mentioned, the high level ones.
Yeah. I want one thing is reserve engineering is for the important mobile application, because authentication code is important, because hackers can reserve engineering and then after they change the code and upload to and Google players or iOS marketing. So I think you are right, access management or other things, but another things, your application must be strong for the reserve engineering. This part is important for the mobile security. Also, they can find, I don't know, it depends of their requirement, open source or commercial. Or OAuth has good guide for the open source tools for not only mobile, web application or other application API. They can follow the OAuth page. They can find some suggestion about the tools for application security.
Sure. So Nikunj, just specifically for you, OWASP, I'm guessing you must already be familiar with OWASP. So you can go to this website, owaps.org. They release, these top 10 security issues, checklist for mobile, API, software security in general. So those checklists can be used as a validation for your QA security testing activity as well. All right. Any other question? Okay, I see one question from. Okay, there are two more questions. One question from Krishna on the pipeline security. Can you talk on the security capabilities at each level? I'm guessing he's referring to DevOps pipeline or CI/CD.
Yeah, my favorite topic, right? So like we were showing you the other slide before, Krishna Prasad. So at each and every stage, right? We talked about right from the collaboration till deployment in the cloud. Every phase, the security in each and every phase is completely different. For example, if you talk about at a code level, which is, for us, code level is you're talking about the version control systems and stuff like that. Now we are ensuring a few things there: vulnerabilities, guardrails, which is the configuration issues of the tool itself, and then the secrets information, especially vulnerabilities with these libraries that we're talking about, right? Open source libraries, whenever people are using. Now, when you get to the next stages, like we were talking about Jenkins, within the pipeline, one important aspect that many tools are missing these days is when you discover the pipelines, sometimes the agent itself is not configured. For example, you talk about a Terraform template, right? You're building the infrastructure, you put your security agent, such as Flying Duck or Snyk or some other agent as part of your deployment process. So the agent gets installed on all these pipelines. But to identify what is not deployed, for example, you might have pipelines before the templates. Now, how do you know if the agent is really part of it or not? So that is something that I haven't seen in many tools. We are doing it. Flying Duck is actually identifying for any missing agents. If the agent is missing, whatever that you have in the template for security is gone. You don't have that capability. So we're also identifying a missing agent as part of the entire process. And then getting into the cloud, we talked about configuration issues at each and every stage of the cloud environment as well. And you can hit me up later if you want more in detail. We could go in much more detail on the topic.
All right, sure. There is one more from Monica. How penetration security testing works for app development and how important it is nowadays.
I can explain.
Sure.
Penetration test or red team exercise is very important nowadays. It is, you know, many application, web, mobile, application running the internet environment. Everybody in the internet environment reached this application. So hackers has time for 7 days, 24 hours in the reach this application and test everything. Penetration test and red team exercise help to for the penetration tester behave like this hacker. Before the hacker hacked your application, penetration tester or red team exercise member find these vulnerabilities, hacked your application like a hacker, and so companies have a chance fix these vulnerabilities before their application hacked by hackers. It is because of this reason, penetration test or red team exercise is important. Also, nowadays, generally, small companies or large companies, they use this. They have penetration tester team, or they can do it for outsources. They test it from the outsource company for penetration or red teams. They understand their cybersecurity resilience, they are strong or weak about cyber attack. It is very important for the development side, but it's generally like this penetration test or red team exercise after the finished application, when your application running the production environment. Yeah.
Sure. So just like any other application, web application, mobile penetration testing is equally important, right? Because at the end of the day, it is source code. It goes the same way. You need to have secure design. You still need to run security tests against the code to find those vulnerabilities, and then API security comes into picture. So it is important topic. I think we pretty much have reached. It's almost 4. Maybe we can take one more question. I think there was one more question that we had received. We haven't discussed cloud, so I thought, maybe we could pick up this one. What are the common security challenges in the cloud typically? You mentioned about misconfigurations. I think Hanim mentioned about it. And I know that the largest security incident that was known on the cloud, Amazon, it was because S3 bucket was open to the world, right? Somebody noticed it and they started copying data. So configuration is really important in cloud setup. So any views on this cloud security? What are the common security challenges?
Yeah, very much 100% we see configuration on each and every service is very, very important. Like you picked up the example such as S3, in a similar way, you have RDS instances, you have AWS Secrets Manager, KMS, the kind of encryption that you use as part of it, encryption of your data, like EBS volumes and all that. Most of these are not by default. You have to go and check for many of these items. For example, we check about 500 plus controls on the cloud, and many clients of ours face the same challenge, and we definitely identify a lot of issues in each and every environment. And other than that, when you talk about the design aspects of it, for example, implementation of DDoS mitigation such as Cloudflare, or implementation of API gateway, or if you talk about AWS implementation of security features that comes within AWS, such as your guard duty or AWS config, all those things are really matter to ensure the cloud is secure.
Correct. And cloud security, like you said, it is a shared responsibility. So it's something, where you cannot just rely on your cloud service provider, right? We have one more question. What is phishing attack, and what can we do to avoid phishing attacks? So I think phishing attacks, we all know, right? It's some fraudster with malicious intent trying to trick you, basically, right, to steal your personal information, either by sending you a link which resembles a genuine, legitimate link. For example, they might send a link for, let's say, HDFC Bank with a little bit change in the syntax or the spelling, so that it appears genuine with the right syntax, the composition of the email. And the idea is that you click on that email, they would ask you to submit your personal info. One way to steal your information. The URL that they would set up normally is a fake website specifically designed to collect your personal information. The other uh, part is, they can send you a malicious attachment virus, right? When you execute that, either your computer gets encrypted, or it kind of gives remote control to the attacker. Yeah. So any other thoughts, Sharat or Hanim, on this question?
I have, phishing attack is popular also, that encryption for ransomware attack. It is how can they prevent? It is, I say again, train the people, because generally security weak part of this people. Therefore, you train your employees, normally, that every company has different department. Everybody don't understand IT very well. You need to train and teach them. You don't click like this link, you check the email addresses, everything, or email headers, then it can be solved very well. Also, some email providers get some configuration for the spam or like these emails, but it is not enough to prevent like these attacks. At the same time, this configuration trained your employer to awareness about like this phishing attack. My suggestion.
Yeah, and that was the most important part, because it's all about educating your staff, people, because it's associated with human behavior. There is one more question. Is there a checklist available for software security auditing? So, I mean, other than the OAups ones that I mentioned,
Yeah, I think OWASP is the core for application security. And also, it's not just about the checklist, right? What we see is we need to understand the functionality of the application as well. So the checklist gives you, certain things that you got to test it out. But once you understand the functionality, and you got to prepare your own set of test cases on how the application works, and what security can be tested based on that. And Santosh, just for the previous question, I just wanted to add one thing about phishing attacks, how to avoid, right? What we saw in one of the cases is DNS and domain security plays a major role, because let's say if there is a misconfiguration in those DNS and domain, someone can actually hijack your domain and send as if they are sending, from your particular domain. And this, we have seen it, and phishing attack is highly possible in this scenario.